little bit about graphically, how do things look between the difference of a graph of a function f of x and its derivative graph h or f prime of x. So the relationship is between a graph and its derivative graph. So all the graphs are in black, all the derivative graphs are in pink. So the original graph 2x, derivative graph 2. Okay, we should know that because derivative graph stands for what is the slope of this line every single place on this linear point. Well, every single place on this linear point, the slope is 2. Therefore, the derivative should recognize that. So the derivative is just a constant 2. Okay, let's take a look at this guy and try to figure things out. So this is a negatively, lead coefficient is negative. It's a downward turning parabola. Okay, so here at 0, what happens? Every tangent slope leading up to the y-axis on the left side of the y-axis would be positive. It would be uphill from left to right. Every tangent slope on the right side of the y-axis would be downhill from left to right. And at the y-axis, the tangent slope should be 0. I draw a tangent, it's going to come right across here as 0. So the graph of the derivative should reflect that. Notice all these values are positive. Don't look at the slope of this line. Look at the values of these lines. The values of g prime of x are all positive. Those coordinate with these tangent slopes being positive uphill from left to right. The value here at the origin, okay, the value here, right here at the origin is 0. Therefore, the slope of the original line was 0, which means there's a horizontal tangent slope. This is normally a turning point of some sort. Okay. On the other side, all these slopes would be negative, so all these values of g prime of x lie below the x-axis. They're all negative. Let's see if we can bring this home in this last one down here. Okay, let's take a look. Notice this graph is increasing until we get to -1. It's also increasing from 1 on out to infinity. Increasing graphs mean uphill tangent slopes. Also uphill tangent slopes. Where do we find downhill tangent slopes? In between -1 and 1. All these tangent slopes would be downhill. Therefore, what do you notice? The values to the left of -1 of the derivative function h prime of x are all positive. The values to the right of 1 are all positive. Where do we find negative values? We find negative tangent values, the same place we find decreasing places on the original graph. Okay, probably too early to talk about this yet, but the reason that this 0 here results in a 0 down here is actually a change in concavity. As this thing is concave down and turns to concave up, that's actually the reason why the derivative flips around here and it forms a little minimum value point here, but we'll talk about that in a later value. Moving on, let's talk about the relationship between differentiability and continuity. Differentiability is stronger than continuous. A graph that is differentiable from -2 to 2 is definitely continuous from -2 to 2. However, the reverse is not true. A graph that's continuous from 2 to 2, which this graph is, I can draw this graph without lifting my pencil. In this particular case, though, it has 2 issues with differentiability. Number 1 is a sharp point. Anytime a graph has a sharp turnaround, I can't really define one tangent slope, so it's not differentiable at that point. Another issue is if it becomes vertical. Any slopes which are undefined basically means an undefined slope means you can't find a value of a derivative at that point. 0 is one thing, being horizontal, vertical is another, so it's not differentiable at this point either. Okay, and in general, anytime a graph has a discontinuity, such as x equals a, it could be a jump discontinuity from here. It could be a hole in the graph caused by a removable discontinuity, division by 0. It could be an asymptote, a non-removable division by 0, vertical asymptote, or even we saw some of the oscillating type of behavior type functions. If they are not continuous, then they're definitely not differentiable at x is equal to a. That's good for today.